Good morning, afternoon, or evening, cats and dogs. Today's video focuses on representing linear functions by graphing equations, finding the intercepts. So we've looked at graphing linear functions or graphing linear equations by making a table, and now what we're going to talk about is graphing equations by finding the intercepts. In class, we've mentioned a little bit about both the x and especially the y-intercept, so we've maybe hinted at some of these words or some of this vocabulary before. So the x-intercept is where the graph crosses the x-axis. That's our horizontal axis. So on this line here, our x-intercept is going to be right here. It's where our line intersects the x-axis, and it intersects at the point -5, 0. The x-intercept will always be of the form a, 0, where a is some real number. It could be an integer, it could be a decimal, but it's wherever that graph or that line is going to intersect the x-axis. Our y-intercept is where the graph intersects the y-axis, which is our vertical axis. It will always be of the form 0, b, where b is any real number. On this line that we have, it intersects at 0, 4, so our y-intercept is at 4. To find the x-intercept, plug 0 in for y. I know that seems kind of weird, but we're going to be solving for x, and we want some number, 0, so a, 0. I use the number symbol, or hashtag symbol, if you will, to represent that, but we're going to have some number, 0 for the x-intercept. In order to find the y-intercept, you plug 0 in for x, and then you solve for y. So the format of that is going to be 0, some number, or 0, b. So as we take a look at our first example, we have the equation -2x plus 4y equals -8. And we need to find both the x and y intercept and then graph that equation. Because keep in mind, we only need 2 points to form a line. So the x and y intercept are sufficient for that. So to find the x-intercept, I am going to replace y with 0. So we have -2x plus 4 times 0 equals -8. That gets us -2x equals -8 since 4 times 0 is 0. Divide both sides by -2, and we end up getting x equals 4. So our x-intercept will be 4, 0. So we're going to go ahead and graph that. So 1, 2, 3, 4, 0 will be right here. For our y-intercept, we replace x with 0. So -2 times 0 is 0, plus 4y equals -8. So that's going to get us 4y equals -8. Divide both sides by 4, you're going to get y equals -2. So our y-intercept is going to be at 0, -2. We can go ahead and connect these 2 points to form a line. So when we do that, our line is going to look like this. Again, all we need is 2 points to form a line. There's really an infinite number of solutions to this equation. These just happen to be 2 of them, and that is our x and our y-intercept. So taking a look at question number 2, we have -5x plus 3y equals 15. To find the x-intercept, we're going to replace y with 0. So we have -5x plus 3 times 0 equals 15. That's going to get us -5x equals 15. We solve that by dividing both sides by -5, and that's going to get us x equals -3. So our x-intercept is going to be -3, 0. We'll go ahead and graph that on our coordinate plane, which is going to be located right here, our x-intercept. For the y-intercept, replace x with 0, so you have -5 times 0, which is 0, plus 3y equals 15. That leaves us with 3y equals 15. Divide both sides by 3, and y is 5. So your y-intercept will be at 0, 5. Go ahead and graph that, and then again, we want to make sure to connect those points with a line. We'll put arrows on both ends that will indicate that this line goes on forever as well. All right, let's take a look at question number 3. So for this one, we have 2x minus 3y equals -6. I do suggest rewriting it as addition, so perhaps rewriting it as 2x plus -3y equals -6. And for our x-intercept, we'll replace y with 0. So we have 2x plus -3 times 0 equals -6. -3 times 0 is 0 and cancels out, so we have 2x equals -6. Divide both sides by 2 to get x equals -3. So our x-intercept will be -3, 0. And that will be located right here. For our y-intercept, we replace x with 0, so 2 times 0 is 0, plus that negative 3y equals negative 6. This is why I suggest rewriting subtraction as addition. That way you don't miss any of the negatives. So we have negative 3y equals negative 6. We divide both sides by negative 3, and we end up getting y equals 2. So 0, 2 is going to be our y-intercept. So we'll go ahead and graph that, and again, connect those. Now keep in mind, you could still graph these lines and you would get the same line if you made a table as well. Graphing using the x and y-intercept is also an option here. So go ahead and connect these, and we'll put arrows on both ends. All right, taking a look at number 4, I did throw a fraction in here, so it makes it a little bit more challenging. I did rewrite subtraction as addition, that way we don't miss any of the negatives. So you can see I did that as my first step. So for the x-intercept, we're going to replace y with 0. That gets us 1/2 x equals negative 4 times 0 equals 2. That leaves us with 1/2 x equals 2. Divide both sides by a half using those inverse operations. And 2 divided by a half, that's the same as 2 times 2, which gets us 4. So if x is 4, our x-intercept will be at 4, 0. We'll go ahead and graph that point on the coordinate plane. It's going to be located right there. So for our y-intercept, we're going to replace x with 0. So we have half times 0 plus negative 4y equals 2. That leaves us with negative 4y equals 2. Divide both sides by negative 4, and 2 divided by negative 4 is negative 1/2. So our y-intercept will be located at 0, negative 1/2. You can also write that as negative 0.5. Now you can see my dot is a pretty big dot here since we have a small graph, so we're going to just squeeze that right in the middle of 0 and negative 1. And then again, we're going to connect those points and form our lines. This line doesn't have a lot of steepness to it, which means it's going to have a pretty small slope. That's something we're going to be talking about as we get into our next lesson, and something you'll see a lot more of next year. But if it isn't very steep, it means its slope is going to be pretty small. In this case, we could solve our equation for y, and that would be able to get us a slope-intercept form, something you'll see next year, and it would tell you what the slope of this line is. But as you can see, it's not going to be very steep. So as we get into numbers 5 and 6, this is questions where we have either a table or a graph related to a real-life situation, and we want to talk about what the x and y-intercept represent. So the directions say to determine the x-intercept and y-intercept of each linear function below, then describe what each of the intercepts means. So in question number 5, we want to make sure we look closely at the title. The title of this graph is The Descent of an Eagle. So it's talking about it descending or going down, possibly from a certain height and possibly down to the ground, which would be a height of 0. So our x-axis is talking about the time in seconds. That's what that S represents. And our y-axis is talking about the height in feet. So when we look at our x-intercept here first, that's going to be at 6, 0. That's going to be this point that I'm going to highlight right here. I'll highlight that in yellow. So that means in 6 seconds, we have a height of 0. So we have to put this into words. Your wording may not be exactly the same as mine, but what I put here was that it takes 6 seconds for the eagle to reach the ground. So we know it's taking 6 seconds to reach a height of 0, so that means it's reaching the ground. So in words, it takes 6 seconds for the eagle to reach the ground. Our y-intercept is where our graph intersects the y-axis, so I'll highlight that in green. That's going to be at 0, 20. So that means in 0 seconds, the height of the eagle is 20 feet. So what I wrote in words for this one is that the eagle starts at a height of 20 feet. Often your y-intercept is going to represent a starting value or starting location. In this case, it's the height that the eagle starts at before it descends. Question number 6, we're looking at Eva's distance from home. The x-intercept is going to be at 8, 0. I'll highlight that in yellow like I did for the last question. And we are given the time in minutes and the distance in miles. So in 8 minutes, she's at a distance of 0, and that's 0 miles from home. So what this means for Eva is that it takes her 8 minutes to reach her home or reach her house. Taking a look at our y-intercept, that's going to be located at 0, 4. And what that means for us is that in 0 minutes, Eva is 4 miles from home. So that's going to be her starting location. So we can say that Eva starts 4 miles from her house, or she's located 4 miles away from home. All right, taking a look at numbers 7 and 8, these are slightly different than the last couple of questions. It says to approximate the y-intercept. What does the y-intercept represent in this graph? So we're approximating the y-intercept because it's between 30 and 35. And I think I approximated it at about 32, maybe 32.50, something like that. But I put 0, 32. So we're looking at the cost of renting a car. We definitely want to make sure to read the title of this graph. I've seen these before, you haven't, so I know what it's about. But it's the cost of renting a car. On the x-axis is the number of miles driven over 150 miles, and the y-axis represents the total cost in dollars. So 0, 32 means 0 miles driven and $32, or approximately that. You might have had a different y value there because we're approximating that location. So we haven't driven any miles, but we still have to pay $32. That's what we tend to call a base fee or a base cost or a flat fee sometimes. So what I said is that there is a $32 flat fee to rent the car. So you're spending $32 to rent the car, and then you're going to pay per mile over 150 miles. All right, let's take a look at number 8. We want to approximate the y-intercept and talk about what the y-intercept represents in this graph. So the y-intercept is going to be located right here. We don't even really have to approximate it. That's at 0.15. This is gasoline usage. Our x-axis is the number of miles driven. The number of gallons in the tank is our y-axis. So it looks like we're at 0, 15, which means 0 miles driven, 15 gallons in the tank. So what I said that this would represent is that a gas tank contains 15 gallons when full, or a full gas tank contains 15 gallons of gas. Now, it does say that the x-intercept is not shown in this graph. It would be off of this graph. But if it were shown, what would it represent? Well, if we have a y value of 0, this would be some number, 0, it would mean 0 gallons in the tank. So what this would represent is how many miles a car could drive. Let me move this out of the way. How many miles a car could drive before it ran out of gas, meaning that it has 0 gallons of gas left. All right, so we've reached the end of these guided notes. I want to double check and make sure I wasn't missing anything. I want to remind you that the x-intercept, again, is where the graph intersects the x-axis. The y-intercept is where it intersects the y-axis. They generally do have meanings if we're talking about a table or a graph that's labeled in some sort of way. If we're just looking at an equation and then finding the x and y intercepts, it doesn't have as much meaning, at least not in terms of a real life situation, but we can identify the x and y intercept by replacing either x or y with 0 and then solving for the opposite variable. So a quick reminder that if you're trying to find the x-intercept, you actually replace y with 0 and then solve for x. If you're finding the y-intercept, you actually replace x with 0 and then you solve for y. I always like to write my x and y-intercept as ordered pairs, and then I graph them and connect those points, because keep in mind, you only need 2 points to form a line. Now, I do want to mention that something you could do for these questions to check and see that your line is the correct line is you could choose another value for x to plug in besides 0 or for y, and then you could solve for the opposite variable. And you could see if that ordered pair, which would be different than the x or y intercept, if that ordered pair would fall on your line. It would be a good way to check to make sure your line is correct. All right, so we've talked about 2 different ways to graph lines, by making a table and by finding the x and y intercept. What we're going to explore next a little bit is slope and what it means for a line. Thanks for listening.